All right, let's dive in. The International Baccalaureate has just rolled out a revamped computer science curriculum, and the first exams are set for 2027. So what's new? And what does it actually mean for you as a student? In this guide, we're going to break down the whole thing, from the big ideas behind it to the actual skills you'll walk away with. Let's get to it.
I just love this quote from the legendary Edgar Dijkstra because it gets right to the heart of what this new curriculum is all about. If you think this course is just about learning to code on a computer, you're only seeing the very tip of the iceberg. The IB wants you to see computer science as a way of thinking. It's a powerful tool for making sense of the world, not just a technical skill.
And yeah, that quote is the perfect setup for the core philosophy here. Before we get into the nitty-gritty of the topics, it's so important to understand the why behind this course. This isn't just another programming class. It's designed to fit into the much bigger picture of the IB's mission.
So you might be thinking, computer science and creating a better world? How do those connect? Well, the IB's take is that it's all about giving you a powerful problem-solving mindset. Think less about becoming just a technician and more about becoming an architect of solutions. Whether that's designing an app to cut down on food waste or maybe building a model that helps predict climate change.
Okay, so at the very heart of this entire curriculum is one core skill, a mental framework that everything else is built on. And it's called computational thinking.
Now, did you catch that key phrase in there? Human or machine? That is huge. This is so crucial because computational thinking isn't just for programming computers. It's a structured way to solve problems that literally anyone can use. It's about breaking down huge challenges logically, and that's a skill that's valuable in any field. Seriously, from business to biology.
This process basically gives you a four-part toolkit. First, you'll learn to decompose massive problems into smaller, manageable chunks. You'll train your brain to recognize patterns. You'll master abstraction, which is the super important skill of figuring out what details matter and what's just noise. And finally, you'll build algorithms, a clear, step-by-step plan for actually solving the problem.
So we have this big idea, this framework of computational thinking, right? But how does it get applied? What are you actually going to be studying? Let's get into the syllabus itself.
The whole curriculum is basically split into two big themes. Think of it like this. Theme A is your foundation. It's the theory, the what. This is where you learn the core principles of how computers and systems work. And then Theme B is where you get your hands dirty. This is the practical, hands-on application, the how.
So under Theme A, we're talking about the big ideas. You'll cover everything from the fundamentals of how a CPU actually works, to how networks connect the entire world, to how we organize data in databases, all the way up to cutting-edge stuff like machine learning.
And in Theme B, you get hands-on. This is where you'll apply that computational thinking by programming in either Java or Python, two of the most in-demand languages out there today. You'll also learn really powerful ways of thinking, like object-oriented programming, which is just a super smart way to organize your code to make it more efficient. And if you're a higher-level student, you'll go even deeper with advanced stuff like abstract data types.
So what's the deal with standard versus higher level? Well, it really just comes down to depth. SL is a solid 150-hour course that covers all the core stuff. HL tacks on another 90 hours, which lets you explore those topics in way more detail and tackle more advanced material. It really sets you up for a tough computer science program at university.
Okay, so you're learning all this cool stuff, but how is it all graded? The assessment is designed to test both your theoretical knowledge from Theme A and your practical problem-solving skills from Theme B. For you standard-level folks, it's a 70-30 split. The big chunk, 70% of your grade, comes from those final exams, the external assessment. The other 30% is your internal assessment, which is a major project you work on during the course.
For higher level, the balance shifts a bit. The external exams make up 80% of your final mark, with the internal assessment accounting for the other 20%. And this kind of makes sense, right? It reflects the fact that at the HL level, you're expected to have a deeper and broader theoretical knowledge base.
Now for both SL and HL, that internal assessment, the IA, is a huge deal. And honestly, it's often the coolest part of the course. It's a 35-hour project where you find a real-world problem that actually interests you, and then you design and build a computational solution for it. This is your chance to be totally creative and apply everything you've learned to something you're genuinely passionate about.
So this brings us to the final and I think the most important question. Is this course a good fit for you? I mean, beyond just liking technology, the IB is really looking for a certain type of student for this course.
This course is built for the IB Learner profile. So ask yourself, are you an inquirer, someone who loves digging into problems? Are you a thinker who enjoys a good creative challenge? Are you a risk taker, someone who's not afraid to try a new idea, even if it might fail at first? And are you reflective, able to look back at your work and figure out how to improve? If you're nodding along to this, then yeah, this course is a perfect fit.
At the end of the day, this course is about so much more than just learning the answers to today's tech questions. It's about giving you the skills and the mindset to tackle tomorrow's challenges, problems we haven't even thought of yet. It's about preparing you to be a creator and a problem solver in a world that will only be more shaped by technology. So the real question is, are you ready?